Assalamu alaikum. Today we will continue the topic of basic programming concepts. So we will start with how to apply lambda functions to data frames. Lambda functions can be applied to each row or column using apply method, as we will see in the coming examples. Okay, so let's look at this example. Here we are loading the data of this file, and we are creating a data frame from that data. Okay, and then here we are displaying the first 5 elements, and here we call the function df.info. We will display the output of that. We will look at it. So our goal here is to look at some columns and do some conversion. For example, here there are some numeric columns. We have C1, C6, and C11. So we want to convert every number, or around every number in these columns, to its nearest integer. Okay, and also we want to convert it to integer, because rounding, it will round it to a nearest integer, but it will not change its. Let's first look at the types first. Okay, this is the data frame. Okay, so these are the attributes of the columns. We have 17 of them. If we look at C1, C6, and C11, C1, C6, and C11, all of them are floating point, right? The data type is floating point. And here we can actually infer all this information. So let's look at the outcome of df.info here, okay? Display df.info. So first thing we notice here is like there are 40 entries in this data. Okay, the total number of entries or rows is equal to 40. And for every attribute or column here or feature, there is 40 non-null elements. That means there is no missing data here. Okay, and here are the data types. Okay, the data type for each column. So as you can see, for C1, C6, and C11, they are numeric, and the data type is floating point. Okay, here there are like 5 categorical attributes, and the rest are all numerical attributes, and the data type is floating point. So for C1, C6, and C11, we want to round these numbers to the nearest integer, and we also want to convert the type from floating point to integer. Okay, so let's start with C1 here. Okay, so the new version of C1, okay, the new version of this column is equal to the old version dot apply. Okay, we're calling this function apply, and takes function as an input, and apply that function to every element in C1. So dot apply, and then we pass the keyword lambda and our function after that. We are familiar with this by now. Okay, we have already explained this. So here we are rounding every element. So we are rounding it to the nearest integer, and then we convert it to integer, because as I said, rounding will not change the type. It will still be floating point. Why do we round first and then we convert to integer? Why don't we convert to integer? Why don't we like just write it this way, integer x? Okay, like we don't round. Okay, this integer x, it will take the integer part of the number. Okay, it will throw the decimal point and decimal numbers. So, it will cancel those. So it will take only the integer part of the number. So 10.9 and 10.1, they will all round it to 10. Okay, they will all become 10 as the outcome of this function. Okay, but here in our case, we want to round to the nearest integer and then convert to integer. So then 10.9 will be rounded to 11. Okay, and 10.1 will be rounded to 10. Then there is a difference here. Okay, so the outcome of this for 10.9 and 10.1 will be different. The outcome of this for 10.1 and 10.9 will be the same. It will be 10 for both of them. So 10.9 is not rounded to the nearest integer. Okay, so let's run this and look at the data after that. You see, so now all of these are rounded, and also C1, C6. Okay, sorry. And now we are doing it only for C1. Okay, C1, every number is rounded to the nearest integer, and it's also the type has been changed. Okay, you can see here, actually look at it here. Okay, the type was floating point, now it's integer. Here it was floating point, now it became integer. Okay, and all, as you can see here, this is C1. Okay, so that is the like if you want to apply lambda functions to a single column, you call the function dot apply. Now, if you want to apply the function to multiple columns, okay, then the only difference is that we call apply map. We don't call apply, we call apply map. Apply map will apply the function that is defined after the keyword lambda to every element in the extracted slice. Okay, so here we are extracting that slice. Okay, this slice is what? Is all entries of these two columns, C6 and C11. So we are the new version of that slice, and here, because we are extracting more than one column, we're calling the function lock. We can call the function lock and pass the titles of the columns, or we can call the function iLock and pass the integer indices of these columns. Okay, so the new slice, the new version of this slice is equal to the old version of this slice dot apply map, and then we pass the keyword lambda and define the function after that. So now we are applying the same function to every element in C6 and C11. And by the way, we could have also done it, and we could have also added C1 here, and then we didn't need this. Okay, C1 here, and that's it. We apply it in one shot. We apply it's just for the sake of explanation here. That's why. So we called apply here to show, like, if you want to apply a function to one column, you can call this dot apply. And if you want to apply it to more than a column, you call apply map. And I think apply map also can take only one column. So in general, it can take one column. So apply map can be applied to one column as well as more than one column. Let's look at the outcome here. So this is it. Now the types have changed, C6 and C11. They became integer, as you can see here, C11 and C6. Okay, we could have also actually applied, okay, maybe. So here, if I pass only one column, it's still, let me just rerun it again here, okay? Okay, so you see, here it was floating point, and here became integer, and we applied apply map to a single column. Okay, so apply map is more general, I would say. Okay, it can be applied to a single column as well as many columns, whatever slice you define here. Okay, to any slice. Okay, so the new version of that slice is equal to the old version of that slice dot apply map. Then you pass the keyword lambda, and whatever function you define after that, that function will be applied to every element in this slice. Okay, so yeah, we can also do some function as we have already explained lambda in the past. It doesn't need to be a numeric kind of function, whatever function. For example, here for C12, the new version of C12 is equal to the old version dot apply this function here. This function is just takes every space in that in any element in that column and replace it with underscore. So if we look at C12 here, C12 is a categorical column. So the data type is a string, and here, as we can see, there are two words, and there's a space between these two words. So here, after we calling this function, that space will be replaced by underscore. So this is before, okay, and this is after the change. As you can see here, the space has been replaced with underscore. And in fact, apply and apply map can be also can be applied for general functions. Okay, so they can take as an input any general function. It doesn't need to be like lambda functions. Okay, so for example, here, if we look into this one here, we have predefined this function. This is our own function. We don't care what the function is for now. It's some customized way of rounding, but this is our function. This is the function we defined. Then here we are extracting a slice, okay? C2, C3, and C9. C2, C3, and C9. They are numeric columns, okay? We are extracting that slice, and the new version of that slice is equal to the old version dot apply map, and we passed the function here. Okay, so apply map is a function that takes a function as an input and apply that function to every element in this slice. So we're going to apply this function to every element here. And this function is nothing but some customized rounding. And this is it. Okay. So C2, C3, and C9, right? Yeah, they have changed it. Okay. C2, C3, and C9. Okay. So now we come to data visualization. And in fact, okay, so when data is small, when we have like a limited number of samples, by looking into the samples, you can infer so much information. But as these data size grows, as the data size grow large, like you have like a large number of samples and large number of features, it become very difficult to get any intuition by looking into the data. Then you need some visualization tools in order to visualize the data and look at it. And in fact, we have already in the previous topic talked about some visualization tools such as the histogram. Okay. And when you look into the histogram, when you plot the histogram is what? Is the is like in the x-axis is the value, and y-axis is the frequency, right? Is the value versus the frequency, regardless of the axis. I can plot the value in the x-axis and the frequency. I can plot the value in the y-axis and the frequency in the x-axis, but it plots the frequency. Let's assume let's take like example when we are plotting the value in the x-axis and the frequency in the y-axis. So it plots the frequency of every value, right? So by looking at the histogram, you can infer many informations, right? First of all, you can see what kind of distribution this random variable or attribute follows, okay? You can also infer information about the centrality, the dispersion by looking at the histogram. You can see like where the center is and how much the data is scattered, okay? And in fact, also box plot is very useful in that sense, right? By looking at the box plot, you can actually tell a lot about the statistics of a random variable or a data attribute, right? And you can see where the mean is located, the lower and upper quartiles, the whisker limits, and are there any outliers or not? So by looking at the box plot, you can tell so much about the statistics of any of a random variable or an attribute. These are like of type univariate. Okay, so these two visualization tools are univariate visualization tools. So you're looking at a single variable. There is a scatter plot. Scatter plot is good when you want to look at the relationship between two variables, how they are related to each other. Is there a linear relation or some kind of quadratic relation or whatever? So by looking at the scatter plot, you will tell if there is a relation or there is no relation. Like the dots are totally random. They don't show any pattern. We will look at all of these. We will come to this as well, line plot later on. So for the visualization, there is pandas. There are pandas plots, okay, and in fact, these are built-in basic plots, and you can actually find them in the function df.plot, and you can pass whatever type of visualization you want to perform using the kind option. So you call the function df.plot, and then you pass the type as the kind option. And there are also functions like df.hist, df.boxplot in order to plot the histogram and the box plot. But our focus here we will not go through the pandas plots. Actually, we will focus in seaborn plots. This is more like I would say this is a richer library. Okay, it has more customized plots. It has more options. The plots here are more, I would say, more beautiful. So we will focus into this one, seaborn plots. In seaborn, the basic things we need to know are the basic parameters are x, y, and the hue. Okay, so in a given figure, we may define one of them, two of them, or the three of them. So if it's a univariate, then we need to define only X or Y. If it's a bivariate, then there is a relation between two variables, X and Y. Okay, then we want to define what is X and what is Y. And if I have a relation, if I want to plot a relation between two variables, okay, X and Y, but the color is controlled by the value of a third variable, then we introduce the hue here. Think of the hue as a different hues are different colors. So the green color is one hue, blue color is another hue, and so on. And we will look at examples. Actually, examples will explain it very well. And this library requires NumPy and Matplotlib libraries. For example, this library actually plots the actual content. But if you want to create the figure, then you still need to use Matplot library to create the figure before you plot the actual content. Okay? And it's integrated with Pandas data. Okay? And we will see now. So let's come to this example. We don't need to go over all these steps here now because actually we will go over them one after the other in the coming cells. Okay, let's start by loading the data and displaying the data here. Okay, so here is our data frame. So we have loaded the data of this file and we created a data frame from that data. And here we're calling these two functions and displaying the outcome of them, the df.head and df.info. So here is the data. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8 features. Okay, we have 8 features, and 3 of them are numeric. Okay, so for every entry, what do we have? Take the first entry. We have the gender, the race, okay, the parental level of education, the type of lunch, standard or reduced or free, test preparation course. So, for example, the first entry hasn't taken any test preparation course. The second entry completed the test preparation course, and these are scores. Okay, so the scores of the different tests or the grades. Okay, for math score. Okay, this is the math score, the reading score, and the writing score. Okay, think of this as some kind of test that you are required to take in order to be to apply to some university or some school. Okay, so these are the required tests: the math score and the reading and writing English. Sorry, the math test and the reading and writing English tests. Okay, and these are the scores. Okay, so if we look here into the info here, there are 1,000 entries, and for each column there is 1,000 non-null elements. So there is no missing data. And here are the types, okay, of the data of the attributes, okay. As we can see, there are, we have 3 attributes that are of type numeric, and the rest are categorical, okay. So, and these are integer, okay. The data type is integer, the numeric ones. Okay, so now we start by defining a new column we give it a name, total score. You see how simple it is to define a new column here. You just use this syntax here, df of, and then pass the name of that column. Then you have added a new column now. This is a new column, and you can give it values in different ways, okay? Here, the values of the elements of that columns are coming from the sum of the content of these 3 columns. So we have these 3 columns here, or attributes, okay? Why it's not... Here. So we have these 3 columns, okay? So we are creating a new column here, where each element here is equal to the sum of the corresponding elements in these 3 columns, okay? Now, this is what we get here. This is the new column, the total score. This is the new column, okay? And every element here is the sum of these 3 elements, okay? Then we're going to now visualize the data, okay? We're starting here by, let me zoom in, okay? Okay. So we import cPorin as SNS, and we also import the matplotlib dot py plot. Okay, as I said, in cPorin we need the matplotlib. Okay, so here we are extracting only the numeric columns. We know this by now, right? We have done this in the past. So we call the select data type. We exclude the categorical columns. Okay, so we exclude equal to object. We exclude the object type of attributes, and we are here by calling this property. Okay, the columns, we are retrieving the titles of these columns. So these are the titles. If we print it here, print. Okay, so we are selecting the numeric columns because we are excluding the object columns. So we are selecting the numeric columns and we are retrieving the titles of these numeric columns. So just the titles. Okay, so then it will be what? These are the titles here. It will be, the first title will be math score, reading score, writing score, and total score. So we are retrieving the titles. Then we are, okay, so we are already actually, okay, interesting. Okay, so it was already there. Anyways, for now, for every column in these columns, okay, for every title in these titles, okay, the numeric columns, for every one of them, we are creating a new figure. We are plotting something. We're going to come to explain that. And we are showing the plot. These are the three things we call. Okay, so the first one is from the matplot library. So we create the figure. This line creates the figure. This line does the actual plotting. It plots the content. And this line shows the figure. Okay, so now what are we plotting here? We are plotting the histogram by calling the function histplot. Okay, the cPorin built-in function histoplot. So we're calling this function to plot the histogram of every column in this data frame. Okay, X is equal to the title, and that title, the column, is taken from this data frame, df. And we are defining bins here, 10 bins, because the data is numeric. Okay, so we don't want to have a bar for every single value. So that's why we are defining 10 bins here. And if you want a specific like bins, then you can pass them like a comma separated inside brackets, right? Specify the start and the end of each bin. Here we are just saying we want 10 bins. Okay, so X is equal to the title of the column, and that column is taken from this data frame. Then what will happen? So we, in the x-axis, we will have the values, and in y-axis, we will have the frequency. So the bars will be vertical bars, as you can see here. Let's look at this here first. So this is the outcome of the calling print function here. This one, print numeric columns. So these are the titles of the columns. Okay, and now we are iterating over these different columns, and we are creating, for each one, we are creating a new figure. And in that figure, we plot the histogram of one of these numeric attributes. So we start with the math score. This is the math score. This is the histogram of the math score. Next one, the reading score, the writing score, and the total score. Okay. The bars here are vertical because X is equal to the column here. X is equal to C. Now, if we put Y equal to C, okay, then the values will be in the y-axis and the frequencies will be in the x-axis. This is the bars will be horizontal. Okay, so you can define it the way you see it. It's more clear to you. I like the x-axis. Okay, so that's it. That's how you actually use cPorin to plot the histoplot. Okay, the histogram. Okay, now for the non-numeric ones here, the same thing. We are extracting the non-numeric ones. Okay, so select data type object. Okay, there we use the keyword exclude object. So we have selected the numeric ones. Here we have selected the object ones. the categorical ones. We're retrieving the titles of those, and then we're iterating over them. But here, because they are categorical attributes, we call the function count plot. Okay, so let's this x equal to c, and this is taken from this data frame. The data is taken from this data frame, df. Okay, this x is equal to c. This here we pass the titles of the columns, and here we define these titles are the data is taken from where? Okay, it's from this data frame. Okay, these titles and which are in this data frame. Okay, or this title. So here, like you're defining the title of the column, and here is the actual content, the elements, the values of the elements. So we run that, and this is what we get. So for the first one, the first categorical attribute is the gender. Okay, so look at this here. This is male. Okay, let me just zoom. So we have two bars because there are two choices or two categories or two classes for that attribute, female and male. And this is the frequency of each one of them. Okay, here for the, I forget this is the race. There are different groups. Okay, as you can see, you can infer some information by looking into this, right? By visualizing the data. So most of the attributes or I would say the one with the highest number of occurrences is group C. Many entries are belong to group C, and the one with the lowest number of occurrences is group A. Okay, and yeah, you can infer this kind of informations. So here are, so as you can see here, there is overlap in the text. I think there is a way to introduce angle here. You rotate these titles. I think we will see it later on. Okay, but alternatively, we can just do y equal to c. Okay, so then these bars will be horizontal bars, and we won't have that issue of the overlapping text, right? Here, there's no overlapping between the different titles. Okay, so as we said here, for this kind of figures, the univariate figures or plots, so you define only either y or x. Okay, we will come later on to where we need to define both x and y when we are plotting a relationship between two variables. And in fact, we will also introduce the hue when we are plotting the relationship between two variables, but the colors are reflecting the values of a third variable. Okay, I think for today we will stop here. We will continue next time, inshallah. Thanks for watching. Assalamu alaikum.